Carpe Diem VPN. Seize the network.
Hey everyone, Tim from Carpe Diem VPN here, and today I'm working on designing my SD-WAN lab. I've already put together the topology at this point, but what I'm kind of working on now is deciding, I guess, what the basic design will be, and then maybe some of the basic considerations we have to take into account when building it out. So I'm going to cover things at a very high level based on how I think it's going to be play out or based on how I'm basically going to set up. And then we'll go from there. All right, so this is the lab. I've got most of it built out, although I haven't done all of the SD-WAN onboarding. I've got all of the underlay built out though. And so what we'll focus on right now is some of the basic issues that we're going to run into with a setup like this. And I built this, I built the topology this way to cause some of these issues because they're common issues that are seen in the real world. And it's stuff that we'll have to kind of work through. And so I'd love to kind of show you some of the issues, and then later on we can talk about how we're going to get through it. So the very first thing I think about when I'm doing SD-WAN design is we start off with just basic, how's the fabric going to be built, and what transports do we have, what colors do we have to work with, and what are the restrictions on those colors. And so when I'm thinking about design, generally how I start design project is I start thinking about what are the constraints that I'm working under. What is the business objective that we're trying to achieve? Of course, is the very first thing in any design project. But once we've kind of established the ground rules, like for example, in this case, we could say that Cletus's Chicken and Waffles had a really good year, and they've expanded to a second data center, add some extra branches, and they're looking to add an SD-WAN at this point. So that being our design setup, if you will, is that we have two data centers. We have a data center interconnect between them. We have some sites that have already been migrated to SD-WAN, and we have some legacy sites, or in this case, just single legacy site to consider. And we'll do migration as part of the design at some point. But we, in the meantime, need to support legacy site talking to SD-WAN sites, and so that's another design piece that we'll cover at some point. So talking about design and finding the constraints, one of our very first constraints is that, okay, so we've got three colors to work with, three different types of transports. An MPLS provider, some kind of business internet provider, say Cox or AT&T, Verizon, somebody, and then a different internet provider, some kind of public internet. So again, it could be Cox, AT&T, Verizon, just different than the other one. And then the SD-WAN control infrastructure is out in the cloud. So we could say that it's, say Cisco hosted. So it's connected through the internet. It's out there on the internet. Let's just kind of go over again an overview here. So in this case, you can see, or you might be able to tell that the MPLS will not have connectivity to the SD-WAN control infrastructure because the infrastructure is connected to the internet, and the MPLS doesn't have any direct connection to the internet itself. That's the very first thing that we have to kind of decide is, okay, well, what colors and transports will have connectivity to the controller infrastructure? There's our very first constraint. Again, when I'm talking about design projects, usually I try to find the constraints because it's a little bit like, drawing a picture or painting a picture where you want to find the edges first, or like building a puzzle, right? So when you're building a puzzle, you tend to figure out, okay, well, the easiest way to build a puzzle is to build all the edges first and then start kind of building inward or finding the pieces that match and so on and so forth. But for me, design constraints are the first thing that help me start to build that picture or find those edges. So let's take a quick look at how the control connections will work over each color, and then that will kind of paint a better picture of what the challenge is going to be with figuring out how our control connections can be built. All right, so here we have a data center SD-WAN box, which is going to have connectivity to all the clouds. And then we have a branch where, say, this branch router only has connection to one of the clouds, specifically the MPLS cloud. When that is the case, in order for SD-WAN router to be controlled, it has to be able to reach the controller. So there's a few options here that we have. Now, under normal circumstances, so for example, DC SD-WAN 1, when it wants to build connectivity to the SD-WAN control infrastructure, it will by default try to see if I can get this working. Yeah, try to build a control connection over every active color. So it'll actually try over MPLS as well, but you can see in this case MPLS is not allowing, so that won't work. Now we'll talk a little bit about how we solve that problem, but so that's the normal setup though, and you can see in this case that with the controllers out here in the cloud, that the SD-WAN routers that have internet connectivity are going to be fine. They're going to be able to reach the controllers. They're going to be able to download, their config and policies and so on and so forth. And there's not going to be an issue. So there will be an issue here with branch 1 SD-WAN router because it can't actually reach the controller infrastructure. So one of the design considerations for SD-WAN is that these routers, even if like DC SD-WAN 1, cannot allow or will not allow another router to kind of build a tunnel through it. So that's not allowed. We can't actually do that. And the reason is because this physical interface here is hardened and doesn't allow us to basically let DTLS connections come in and then move out of the same, different interface. It's just hardened, and they don't allow that by default. So right off the bat, we have a design consideration to solve. And there's a couple ways to solve it. There's a thing called TLOC as loopback, or mapping a TLOC to a loopback. And that's one of the ways we could solve this. And how it would work is that the tunnels themselves would actually be built from a loopback. So it would go through the physical interface and then out to, say, the SD-WAN controllers or other boxes. If you could say if there was another SD-WAN router out here, it would also build an IPsec tunnel from the loopback here to the interface here. And then that would be an IPsec interface instead of a DTLS control interface. The difference here, or the issue here that's potential, is that the loopback has to be known and routable for that to work. So in this case, the loopback as TLOC would only work over public internet if this loopback was actually an internet routable address, say 100.64. And this is not internet routable, by the way. This is not an internet routable IP, but not a local or LAN-based IP is my point. So say it was 1.3 or something. And as long as this router knew how to route back to that, and every router in between, the IPsec tunnel would actually be established from the loopback and not from the physical interface. And why that is significant, that this is significant for a good reason. The same is true of MPLS. Let's say it was, 172 or something, so on and so forth. Let's just say that MPLS was bound to a loopback, and that this loopback was advertised into the MPLS network. Now, because this physical interface is not the tunnel interface, it'll work like a normal router interface. And so when branch 1 SD-WAN 1 comes here into the MPLS network, as long as DC SD-WAN router is advertising something, a zero route, or even the more specific routes for the controllers themselves, whatever that is, as long as the SD-WAN router can attract that traffic into that physical interface, there's not a hardening here. The hardening is actually right here on the loopback. So this actually works like a normal router, and then it would just forward that request over its normal, whatever routing decision it makes, right, to get to those SD-WAN controllers. And this tunnel then could be built through this SD-WAN router. So that's one way to solve a problem where you have a control connection. And again, we're focusing on design here, right? And I'm not trying to get too technical, but we're talking about design constraints, and we're talking about the ways that we're going to think about some of the design challenges and how to solve them. So I'm just going to, right off the bat, here we have one, And here's one of the ways that we could solve that design constraint is we could do loopback as TLOC. Now this, of course, using loopbacks or TLOCs introduces a layer of complexity in the config, in the just remembering how it all works. It's a little bit more complex, but it allows you to ease the constraint and to provide a solution that you need, because this SD-WAN router at the branch has to be able to connect to a controller. To get its policy, to get its config, it has to be able to connect to a controller on at least one of the transports. One of the other ways we could have solved this problem, or might solve this problem, still, is that there could be, at the data center, there could be a non-SD-WAN router, just like a normal MPLS connected router, right? And that normal MPLS connected router could, could do the same thing, right? Like maybe it has connectivity to one of the internets or both of the internets, or has connectivity to the firewall that provides connectivity to the internets, right? So this not being part of the fabric and this not coming through a hardened tunnel interface, this would still be on the underlay. So this would not be part of the fabric, but it would facilitate connection to the fabric, if that makes sense. So that is another way to solve the problem. If the router is available, if you have circuits available, ports available, IPs available, and if loopback as TLOC is not an option for you for multiple reasons, one of which being here, where your loopback has to be routable, right, over the internet. So that's one of the design constraints that we would want to work through, and that we will work through as I build this lab. All right, one of the other design considerations we have to think about is firewalls and DMZs. So in this lab, I've built 2 different data centers, and I'm using different firewall setups in both data centers. In one data center, we'll have a no-NAT DMZ. And what that means is that while the firewall is directly connected to the internet transports, and it provides connectivity to the SD-WAN boxes in DMZs, the firewall itself is more or less just inspecting and routing. It's not doing a NAT. We're assigning public IP addresses to the SD-WAN boxes themselves. And we'll use sub-interfaces so that we're only using one port for each transport. So the SD-WAN boxes will have 2 different IPs on the same physical interface, split out via sub-interface. And then the firewall, of course, is going to be what actually forwards that traffic onto the transports. But the important thing to note here is that the firewall itself is not going to provide any NAT. It's just going to route the packets. So this would be something you could set up when you have a DMZ that where you have public IP addressing that you can assign to your SD-WAN. So you would assign those interfaces, assign those IP addresses to those boxes, and then the firewall again would do the inspection for you, but more or less just route the packets after that. So it would be built through the firewall. The other option in the other DMZ is what I've done is I set up a NAT DMZ. Now the NAT DMZ comes with its own considerations that we have to think about. Obviously the big one being that the firewall is going to perform NAT for us. So we're going to conserve public IP addresses. Say if our provider only gave us the one, or if they're all in use elsewhere, but we need to go through the firewall anyway, we're going to set up a public IP address on the outside of the firewall, and then we're going to NAT it to some kind of a DMZ inside for the SD-WAN routers. So say on the outside, we will have our public IPs, and I don't know if these are entirely right, but just for illustrative purposes, let's set up, say it's like 198.19.11.2 and 198.19.12.2. And I don't know if this is right, so I'll have to go look at the lab later. And then say on the SD-WAN side, we will configure a sub interface. So it'll have 2 colors. It'll have connectivity to both transports, and it'll be, say, 10.2.255. 2 and 10.2.255.6. Again, it's not important what the IPs are, just that they're different. And we're going to tie them via the NAT to the different transports. And we're going to NAT them to the different physical interfaces. So that means that the firewall is going to be doing a lot of our work here, right? So when a firewall sees a packet come in from the SD-WAN box, on this subinterface, we're gonna have a NAT of some kind, either a port overload, a NAT overload PAT, or maybe a static one-to-one NAT. However we decide to do it. And this again is part of the design. We're going to make sure that that packet coming in from what the SD-WAN has allocated that interface to the color pub internet gets actually translated to the transport for pub internet. Otherwise, things would get really messy really fast. So we definitely want to make sure that's one of our biggest design considerations, is to make sure that whatever we come up with, that the SD-WAN's view of the underlay is accurate to which way it's actually routing. So the packet come into the firewall, get translated either to the interface or maybe to a NAT pool or however we're going to do that. Let's say in our case, we're just going to straight up translate it to the interface IP. And then, that packet will be translated and sent out towards the controllers or IPsec or whatever. And then on the other side, we have the same thing set up with this SD-WAN router, right? Where we're going to have two IPs, and I'm not going to waste time writing all the IPs and everything down. You can imagine it's going to be the same. And the point is that here, the firewall is more or less multiplexing these connections and figuring out how to NAT them. So again, we'll do like a static NAT, or we'll do a port overload, like just to translate to the interface type of setup. And what you will see as we kind of dig in this specific design later is that which way we choose to do the NAT is going to inform other things, like what ports we have to allow to be opened on the firewall, specifically for the connections to be built. So that's another design consideration we need to think about as we build this fabric and as we deploy this lab. So there's a lot more design considerations to think about, and I'm going to do a video on, again, more of the overview of some of the other design considerations we should think about. But I think it'd be kind of boring if once we start digging into it, that I just kind of sit there and drone it off and just talk about it in a vacuum. So what I would like to do, if there's interest, if people are interested in work with me and hanging out with me for a little bit, what I would like to do is actually invite some people that I know, whose opinions I respect, who know SD-WAN and know design really well. And I'd love to get their opinions on how we should set it up, how we could set it up, just talk through it a little bit, have a little bit of a dialogue, because I think that's more interesting. And honestly, I don't know everything, and I know I don't know everything. So I really, if there's one trick I would say, as you learn more and more about design, the more you realize that you really need peers to work with who can kind of see your blind spots for you and can offer that different perspective. And I think that's really, really valuable. So I hope this was somewhat informative, especially for those who are kind of studying design and also studying SD-WAN. Just to give you a good start on, okay, well, here's this very specific thing. How would I start thinking about the design considerations for it? How do I start thinking about design? So I'm going to reach out to some friends of mine, see if they'd be interested in working with me, see if they'd be interested in hanging out for a bit, and then just work through the logistics of how to do that. And hopefully some of the later videos where we're getting into very specific design considerations will be, well, I'll have some people with us to talk about it. So thanks for joining me.